All right, let's get going. Welcome to Comp 15. Woohoo! Most of you probably took Comp 11, so you kind of know the drill of computer science courses here at Tufts. I will go over some details, lots of details about the course and so forth in the next hour and 15 minutes, I guess. So my name is Chris Gregg. That's my email address. Feel free to email me. We'll talk about how much email you should send me later. It should be sparing if you can, but we'll go into that. If you're not enrolled in data structures, actually, if you're not here for data structures, you are welcome to stick around. But if you're actually enroll or on the wait list or whatever, we will talk about the details of that. The bottom line is it looks like everybody will get in off the wait list, so that's good. We'll chat more about that. If you have specific situations, let me know. Question already? Yeah.
It's about the wait list.
Okay, hold off on it for a few minutes. We'll get to that in a few minutes. You guys know where most of you guys are sophomores. You guys know where the cannon is right around the corner here, right? I was here this summer. I happened to walk by it and saw the best cannon painting I've ever seen here. Did you do that? No kidding. It's awesome, right? It's awesome. And for those of you in the next 3 or 4 years here at Tufts, strive for this, right? Don't strive for like handwritten, drunken, sigma, chi, epsilon, forever, right? That's what half of them look like, right? Don't do that. No, strive for the art. Okay, so awesome, good. Okay, so what are we going to do today? Well, we are going to talk about 4 different lists. Okay, actually, we're going to talk about 5 lists. One list is the wait list. We're going to actually do a little computer science before we get too far into anything. But this is the schedule for today. I will answer all of your questions. We may end a few minutes early just so we can answer any other questions, or I will stick around after to answer any other questions about wait lists and other things if you have specific questions about the class. But we'll talk about 4 lists. That's the computer science part of today's lecture. Then I'm going to kind of introduce myself. I'm going to introduce 1 or 2 of the TAs. Hugo's here. Any other grad TAs here? Yeah, Tomoki's in the back there. Anybody else? No? Okay. And then, are you going to be able to stay the whole time? Okay, great. We'll find a seat if you're going to stay the whole time. And then we'll talk a little bit about labs, assignments, course goals, kind of a little bit on, hey, what's this course all about? And actually, we'll do that kind of at the beginning. And then introduction to Eclipse, which is an integrated debugger that I will highly suggest you guys use this year. Some of you may have used it before if you took a Java class or AP Computer Science or something like that. If you took Comp 11, you probably didn't use Eclipse, but I think using it will make things a little bit easier. You can also use Xcode or any other IDE you'd like in this class. That's perfectly fine, but we'll get into some details about that. And then we'll talk about the first couple of assignments. Okay? All right, before we do anything else, let's talk a little bit about some computer science. We'll get into the details of the admin stuff later. We'll kind of flip it around a little bit. All right, on the syllabus, which is on the web page, which we'll talk about later, on the syllabus, you will see the following statement. Students will be able to solve real-world problems by making appropriate data structure choices tailored to the problem. Well, that's a lot of words to say. We're going to make you a little smarter in computer science, right? A little smarter in how to write programs that are efficient and that you're smart about, right? You also will see how to analyze the costs associated with programming choices. Again, a lot of this class is going to be learning about the choices, but a significant portion of the end of the year is going to be how do I make choices for my own programs that run efficiently, meaning fast, and that don't take up too much space, and that are the right choices to make, okay? A lot of times I call this class, Comp 15, how to get a job at Google, right? Because companies like Google and Microsoft and Amazon and all those big tech companies ask questions based on Comp 15 data structures material. If you've ever done a technical interview, well, most of you probably haven't quite yet, but when you do your technical interviews, if you ever want to get a job in the computer science field, questions from this class will come up all the time, and hopefully you'll be able to knock them out of the park, right? Okay, what do we mean by some of this stuff? Students will be able to solve real-world problems by making appropriate data structure choices. That's all about, again, what choices you have of available data structures and how you actually can figure out which ones to use. I haven't even really told you what a data structure is yet. Now, I assume most of you guys have taken some programming class before or some other form of computer science-y type course where you kind of have a basic idea of what a data structure is. You probably don't know about all the ones we're going to talk about in class. In fact, I'll talk about a couple in a minute that you've probably never heard of. But from the standpoint of you kind of have an idea of a data structure is where you put your data, right? And that's the big idea of this class, is you've got all this data, all this information, and you're trying to organize it such that the computer can process it efficiently. OK, one reason we care about data structures being important, right, is time. OK, when the worst thing about your computer right now is probably when you have to wait for it to do something, right? That's like it's like annoying, right? Now, if you put yourself in the computer's perspective, the computer is waiting for you like 99.999999% of the time, right? I don't know if you guys, for your cell phone, if you're doing a text in your cell phone, right, and you're like actually typing a text, every time you put your finger down, the computer in your phone has to do something. When you lift your finger up, the computer has to wait so long in its own time that it actually goes to sleep for a little bit, right? While you're picking your finger up to go to the next key, your computer's like, he's not touching anything, I'm done. And it like goes to sleep and then wakes back up when you touch the screen again, right? So the computer's waiting for you most of the time. But in many cases, we can actually make the computer like do something that takes a long time, right? And that's kind of a lot of the things that we're going to talk about in the classes. How do we speed these things up? Because time is really key to a lot of these ideas. Here's what I'm going to do. I'm going to show you 4 different list-like containers. What do I mean by a container? Okay, here's what a container is. Okay, and on the board here, I'm going to just write a little box, and in that box, that's my container. And I don't really care in the sense of when I'm using a container, how it handles things internally, right? I'm going to put some numbers in here. In fact, we're going to have 4 containers, and we're going to add 100,000 items to each container. It's actually kind of a lot, right? I mean, how often do you have 100,000 integers that you need to manipulate? Places like Google, if Google's laughing, you're like, that's not much. But 100,000 for our purposes is a lot. We're going to put some numbers in there. In fact, we're going to put the even integers from 0 to 200,000 in this container, right? We're going to do 0 and 2 and 4 and 6, all the way up to 199,998 in this container. Okay? And we're going to have 4 different types of containers. The type of the container is not important right now, but the results of what happens when we do this is what I want you guys to think about. Okay? So we're going to add all those elements to each container. And I've written a program about this. You can go look it up. It's on the lectures page of the website, and you can look at it. It's 4 different containers that are not optimized. I just kind of knocked them out. And what we're going to do after we add those 100,000 integers, we're going to search for 50,000 of them. And in fact, we're going to search for the first 50,000 integers plus 0, right? 0, 1, 2, 3, 4. So basically, we're going to say, hey, container, do you have the number 0? And the container says yes. And then we say, hey, do you have the number 1? And it says, nope, I don't have 1. And then 2, and then 3, and then 4, all the way up to 50,000. So far, so good? OK. So we're going to add the integers to the container. We're going to search for them. Then we're going to delete 20,000 of them. OK? We're going to delete 20,000 of them. We're going to try to delete the first 20,000, starting at 0 again. OK? And same sort of thing. We're going to say, hey, container, delete 0. And the container goes and finds 0 and deletes it. And then we're going to say, hey, container, delete 1. And the container is going to go and look for 1, find that it's not there, and then not delete it because it's not there. OK? Get the idea? All right. So that's the basic thing. Now, question is, what are the results for these 4 different containers? And of course, I haven't even told you what those containers are yet. But here's the results. OK? We have 4 containers. You may or may not have heard of any or all of these. Hopefully, you've heard of an array. If you've been doing any programming, you probably have used an array at some point or another. OK? I ran these on the homework server. For those of you new to Tufts, that's the server in the CS department that we will be using for class assignments. It's a decent server. We only used 1 core on that server. Turns out the server has 64 of them. I only used 1 for this one. And there's some other details there about the container, about the computer. And then there's the overall results. OK, so the array. Okay, the array, which by the way, if you don't remember already, is just, on the board I'm just drawing a set of boxes here, one long line with a set of boxes in them, right? And an array is just one box after another, after another, and after another, and it's got those integers we put in it. 0 is the first one, 2, then 4, then 6, etc. Okay, that's what an array is going to look like. For an array, the overall time to insert, search, and delete is going to be, in this case, 9.8 seconds. All right? It doesn't really mean anything out of context too much, but that's how fast it is. A linked list is another data structure. Many of you guys probably did one in some linked list things in Comp 11, if you took that. Linked list data structure took 23 seconds to do that. Not so good, right? Remember, this isn't optimized, but as it turns out, linked lists are not particularly good containers for what we're trying to do here. Okay, hash table. Now, another data structure called a hash table, which is kind of awesome. Right? If you look at it here, the hash table did those three things in 0.02 seconds. Right? Wow, that's fast to do all that. Okay? Binary tree, 0.06, also very fast. Not quite as fast as a hash table, but also very fast. And then a sorted array. Now, turns out that the array we had was sorted, but I pretended I didn't know that. All right? And then I wrote another program that actually explicitly put the integers in a sorted way. That was also relatively slow, but still faster than the actual non-sorted array. OK, what can we learn from this? What's one thing we learned just from this little thing? Yes?
That at least in this particular situation, there are certain data structures that are way, way, way faster than others.
Indeed, yes. There are certain data structures that are way, way, way faster. In fact, in this case, the hash table is very fast. Anybody ever programmed in Python before? Yeah, if you've ever programmed in Python, Python's model is if it can be stuck into a hash table, stick it into a hash table. Like this is all behind the scenes, right? Why? Because hash tables are fast for a lot of things. And in this case, hash tables are really fast. Now, why are we going to learn about linked lists if they're so kind of terrible at this thing? Well, they're good for some things, but it's also a structure that we have to know because other structures build on the linked item idea. Okay? All right, so 1,280 times difference for an array. If we made the hash table, if we gave this enough integers such that the hash table took 1 second to run, right? The linked list would take 1,200 seconds to run, right? Which is the better part of what? A half an hour or so. You would not want to wait around for that, right? If you wrote a program at a company that took half an hour and it could have taken 1 second, you'd probably be fired, right? So also if you said in your Google interview, yeah, I think I'd use a linked list for this, and it was like this sort of thing, right? Nope, out the door. Okay? All right, so those are some of the little results. Here's kind of the results broken out a little bit more. Okay? What is the structure here? Well, for these different structures, if you look, arrays, whoa, really fast at inserting, right? Super duper fast at inserting, right? And it kind of makes sense, by the way. A computer's in the bottommost level, a computer is based on an array. And to put another number right after one is easy, right? So it's very fast to insert into an array. Linked list, also pretty fast, as it turns out. Not too much to inserting into a linked list. It's not too bad. Hash table, pretty fast. But also notice hash tables are slower to insert. Okay, there's a very key reason why that's the case. Binary trees, also relatively slow to insert. Not slow, relatively slow. And then a sorted array is that's the way behind, in terms of inserting. Because you got to keep the thing in order, right? You have to keep the thing in order. Searching, you can kind of, I won't go over the details of this. You can look at it on the slide. But the searches for hash table, amazing. Binary tree, pretty good. The other ones, not so great, except for a sorted array. Sorted array searching is phenomenal, right? It's great. It actually beats a binary tree. Although that's probably my implementation in this case, about why it does that. And then deletes. If I want to delete the number 6, what's the first thing I have to do? Find it, right? So isn't it basically deleting is search first, then delete? There's two parts to search, right? Deleting is an important one because you not only have to find it, but then you have to rearrange your structure somehow, possibly, depending on what you do. Okay? All right, so why are there these discrepancies? Well, bottom line, there's two real key things here, right? some of these structures, or lists or containers, carry more information in them. Okay, by the way we access them and by the way we actually kind of control where the data goes, that's actually more information. I mean, at the very base level, it's all about, I have now put information into this list such that I can now utilize that information to do something much faster, like later when I want to search or delete. Okay? The other big one is it takes time to do these manipulations, right? It takes time to do a delete in an array for the following reason. So on my board I have 0, 2, 4, 6, 8, 10, 12, right? If I'm going to delete 6, right, there's two different ways to do it. One is to find 6 and then erase it, and then, actually there's a number of different ways. But in an array, if we don't want to make the array like keep getting bigger, one of the ways to actually delete this is to move 8 into where 6 was, and 10 into where 8 was, and 12 into where 10 was, right? And that takes some time, right? That's actually how I implemented it here. Anybody think of a better way in this case, if we don't care if it's sorted? Yeah?
Take the n number, move it in there.
Yeah, take the n number, 12. We only deleted one thing. Let's just move one thing. That's not a bad way either, right? And if it's not sorted and we don't care that it's sorted, that's very fast. So yeah, good call. You move the 12 into the middle there, where the 6 was. Okay? All right. So it takes some time to manipulate the actual structures. Okay? And those are the two kind of key things here. I mentioned it a couple minutes ago. Computers know one thing, right? Computers know about arrays. Like the actual hardware knows that there's a big long list of addresses, and in those addresses is where you put data, and they're one after the other after the other. That's an array, right? The computer, that's all the computer knows. All of these data structures that we are going to create have to be they have to be fit into this model in some form or another, right? They do not have to be in a row like this. We could have the 0, and then that points over to the 10, which points over to the 4, which you see what I mean? You can have your program, or the data structure that you're going to build, manipulate the abstract nature of where things are in a much different, as much as you want. And that's where we're going to get some of these time increases. Yeah?
Are there situations where it's advantageous to hybridize data structures so that you can move through them in different ways?
Yes. The question was, are there times where you might want to make a hybrid data structure? Absolutely. Yeah, we're probably going to stay away from most of those in this class. But sure, if you can think of a better way to, there's a thing called a skip list, which is basically a list where you're able to jump from one place to one place kind of in a random way. And that's kind of a hybrid of a couple different ideas. So yeah, absolutely. Yeah, we're going to talk about the ingredients for all these data structures and then the individual data structures. But if you want to, there are ways to make them hybrid. Sure. OK. All right, so let's see. Let's go through a couple more details here. The array versus the sorted array, right? I kind of already mentioned this, right? In the search for I didn't mention how this actually works. For the array, to search in an array that you don't know is sorted, or one that's not sorted, all right, you have to go through and you have to say, are you 0? Like if you're looking for 6, you go to the first one and you say, are you 6? No. Are you 6? And you go to the second one, are you 6? No. Then you go to the third one, are you 6? No. And then you go to the fourth one and it's 6, which I deleted. It's 6, right? And it says, yes, I'm 6. And then that's how long it takes. You have to go through every one until you hit the final one, right? Remember what we did for searching? We searched for all of we put even integers into our containers. And we searched for all the integers. So every other integer, what happens in an array? Goes all the way through, looks at every single one, and says, no, I'm not there. Right? The one you're looking for is not there. Right? Half the time you have to look through everything. That's why searching in an array without knowing if it's that it's sorted is slow. Right? A sorted array, though, is beautiful. All right? You've probably programmed this before. You might have done it in Comp 11, but you've all played the game, like guess a number between 0 and 100, right? Or 1 and 100 or whatever. And then the person who has the number says whether your guess is too high or too low. You played that before? Between 0 and 100, what's the first number you guess? 50, right? And I say, no, it's lower than 50. What's the next one you guess? 25, right? You're splitting it in halves. That is a huge, huge idea in computer science, is this idea of breaking a problem down into halves. That's how a sorted array is able to search so quickly, because it cuts the list in half, then it cuts it in half, then it cuts it in half, right? That's a logarithmic way of doing business, right? And so that logarithms are really important to speeding up programs. If we can cut a problem in half, 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 or a third, a third, a third, or whatever, then we will greatly speed up the process. Okay? All right. Let's see, a couple more of these. Deletes. In an array, I already mentioned this. In an array, you have to move everything. Or if you're smart, you just move one, right? In a hash table, you don't have to move anything. You just kind of pick it out. There might be a little bit of extra cleanup you have to do, but in general, you don't have to move stuff, so not very slow. I already said this. You have to search before you delete. Why do deletes take less time than searches? Any ideas? Yeah.
Because you don't need to go through the whole list. Once you find it, you can just delete it.
You don't need to go. Well, you still need to search it though. And searching was the exact same, well, okay, by the way, in this case I forgot. We didn't delete the same number that we did before, so this is actually somewhat lying to you. But in the sense of, we still do have to do the search though. So that part is going to take the time regardless. Somebody else who hasn't, yeah?
Does it have to do with the way of the hash table structure and the fact that when you're searching for it, then it needs to go from one.
Not in the hash table. I'm just specifically talking about the array. Notice how the array takes less time. I'm trying to trick you in some sense, yeah.
Because you already did it before, so it's like the second time you do it, it's faster.
You're kind of exactly right. In some sense, well, no, sorry. I think what you're saying is, sorry, you're not exactly right. I misunderstood you. I think what you're saying is you've already done the search before. There are things like caching which could speed this up. That's not what I'm talking about. Yeah.
Every time you delete something, the list gets smaller.
That's it, right? Is that what you're going to say as well? Yeah. Yep. You do have to move everything over, but every time you delete, the list gets smaller, so you don't have to look through as much every time. So you gain the benefit of doing that, right? If you're continually making the list smaller, it's going to speed the whole process up. So kind of a trick. Okay. Let's see. This one, inserting in a sorted array. I already mentioned that. We've got to give the array more information. By making sure it's sorted, by giving it that information, that takes some time to make sure it's in a sorted order. And by the way, my sorting, like insertion sort, was a terrible sort, but that's a different story. Okay? All right. I think that was about it. Any questions on containers? Did I pique your interest in the kinds of things we're going to be talking about in class this semester? I hope so. We will do a lot of this kind of analysis, right? Our analysis is going to be, it's in some sense, there's going to be a little bit of math, but I mean really logarithms is like the most you're going to have to worry about. But more often than that, you're going to have to think about what information and how have I structured this data structure such that I get more information and I can make things faster than other things. Okay? All right. Any questions about that? Just kind of a little thing to whet your interest in this. Okay. Now let's do the admin part. So we talked about that, the rest of it. Data structures. Okay, first of all, a lot of you guys are worried about this. If you enrolled in the class and were put on some wait list or whatever, it turns out that I think at this point we've got it such that everybody will get in. Okay, if you came in a little later, some people got these already. I have sheets that you can fill out if you are on the wait list, and I will sign them and hand them in, and you should be off the wait list soon. I believe I put everybody on Piazza, so you should have got an email from Piazza saying, hey, go register if you haven't or whatever, right? What else was I going to say about the wait list? I think that's about it. Anybody have any more questions about the wait list at this point? And I think we solved it for the most part. Yeah.
Does that include like people who weren't able to sign up at all?
Yeah. If you weren't even able to sign up at all, just come fill out the form and you should be good. Right now we've got about 150 people between the two classes. If that gets more like 170, we'll have to start like thinking about who's getting in. But I mean, it's a matter of if you're filling out the form now, you're in good shape. Okay? All right. I don't really care which section you actually attend. Now, if you'll notice in here, it's really crowded, right? Now, there are those of you guys, there are extra seats, by the way. You don't have to sit on the floor. But it is pretty crowded. If it gets to a point where it's like no seats left, I'm going to make everybody who's not in that section stand up, and then everybody else sits down, and then you get to find a seat. So I don't really care which one you go to. There's another section at 4:30 p.m. in a different building, but that's another one you can attend. If you don't want to come at all, that doesn't bother me either. Here's why. Okay, there's a caveat to that. Don't just like blow off the class and say, Chris said you never have to come. But if you'll notice, maybe some of you guys over there might be able to see, there's a camera back here. I'm going to tape all of the classes and put them all on YouTube. Okay, I did this last year. It seemed to be a good thing. A fair amount of students watched the videos. A few watched the videos and just never came to class. And the downside to that is you can't ask questions during class, and I might not learn your name if I like never see you, right? I'll try to learn everybody's name. I'm not going to promise 100%, but I'll do my best. And so anyway, the videos will be online generally about a day after the class. I try to do it that afternoon, but sometimes other things get in the way and I can do it. But if you don't see the video after like a day, email me. Now, what does this also mean? It means if you come to office hours, and this goes for me or the TAs, if you come to office hours and you say, oh, I didn't go to class, can you tell me what we did in class? I'll say no. I'll say go watch the video, then come back and we can talk, right? If you're not going to come to class and don't watch the video, well, that's your problem, not my problem, right? Okay, questions on that? Yeah.
So what will the videos be called?
I don't know what they'll be called. Comp 15, day 1, day 2, day 3. I will put a link. The link will be on there, and it's just going to be on the lecture part of the web page. Yeah. Unless you have a better idea, I could call it something else. Yeah.
Can we still sign up for labs from the waitlist?
Yeah, the waitlist is completely separate from lab sign up, and we'll get to lab sign up now. Labs are mandatory. There are going to be, I think, 7 or 8 lab sections. We're going to do them all on Monday evenings and Tuesday before now, right? So basically, we're trying to get everybody in between classes. Okay, so that may be a problem for some people signing up. But at 6 p.m. today, you can go online, and on the class web page, you can go in and sign up for a lab. Okay, and it will tell you. You can try it now, and it'll say it's not open yet. All right, but once it becomes 6 p.m. today, you'll either go in there and sign up for a lab. And like I said, there's about 8 different lab sections. The labs hold about 24 people, well, 22 people, I think, is the official word. And if you can't find any because you were too slow on the mouse button, then you'll have to talk to me about it. Question?
What's the possibility of like more labs being added Tuesday night? Because I noticed right now they end at like 5:45. I think is the earliest they get.
Right. Here's we can think about that. If it comes down to so many people need a lab after Tuesday night, then we may add another one. Part of the problem is staffing them too. I mean, we've got to have TAs that do it as well. But that's that. Okay. Question? Yeah.
We signed up for a lab on the website like a week ago. Was that last?
That was last. Yeah. Sorry. That one was still open. Yeah. Sorry. I didn't know that. I didn't know that was still open from last semester. Yeah. Yes.
Sorry, where are we going to sign up?
There's a on the web page for the class, which I'll put up in a minute. There is a sign-in area there. You'll see it's like the first or second bullet says how to sign up for labs. Yep. Anything else on labs? Okay. Let's see. Before we get into instructional staff, a couple comments about. Well, actually, this is kind of coming up in another one. Yeah, this next one. I'll talk about instructional staff. Okay, me, right? I've already talked a little bit about me. Should I go and give you the whole spiel? Might as well. Why not? This is where I was born. Right? Let me see if I can make this a little bit bigger. Hang on. A little place called Skaneateles, New York. Anybody ever heard of it? Yeah, you're not from that area, are you? No kidding. Okay, very cool. Very cool. And I lived there until, this is a beautiful lake, by the way. It's phenomenal. And I lived there until I went to college, which was at Johns Hopkins University, which is in Baltimore, Maryland. I spent 4 years, as you do, in college studying electrical engineering, and enjoyed electrical engineering. I loved it, and had a great time there. I actually looked at Tufts. Tufts was probably as it turns out, one of my top choices. I ended up at Hopkins, but you guys know about choices, I'm sure. let's see. Then after Hopkins, I actually went into the Navy, believe it or not. I went into the Navy. Why did I go in the Navy? Because they sent me a letter. They said, hey, you want to join the Navy? And I said, sure. Which, in hindsight, it was an okay decision. The Navy, it was a pretty good decision. I ended up as a cryptologist in the Navy, which sounds pretty cool. I ended up pushing more paper than doing kind of fun stuff, but that's kind of the way it goes. In the Navy sent me some cool places, though, I have to say. Navy sent me to, well, they sent me to Florida first for a while in training, and then they sent me to San Diego. Anybody Californians here? Where are you from? Yeah, I love San Diego. It's really one of my favorite places is San Diego. I've also lived in Santa Cruz and San Francisco and a couple other places as well. But I hope the winters don't kill you here, by the way. Hopefully they won't. Should be nice. Anyway, I spent a few years in San Diego. I actually went a number of different places. While I was on ships out of San Diego, I went to the Middle East a couple times, went to a ton of different cool countries like Australia and Thailand and Malaysia and all these fun places, and Hawaii and so forth. And that was a good time. So like I said, in the end, I'm kind of glad I did that. Then the Navy said, where would you like to go next? And I said, how about Australia? And they said, sure. I was thinking there's no way they're going to send me to Australia, but they did. They sent me to this little tiny place in Australia called Gerringong. Actually, it's south of there is a place called Nowra. No Australians in here? Do we have any Australians? Sometimes we do. And that was amazing. I got out of work at 4:30 every day and went surfing, and it was great. I loved it. Right? It was terrific. And then after Australia, I decided, hey, I want to go be a teacher. I'm done with the Navy. I was just in the place. I realized I would never be able to find a job as good as the one in Australia, right? They were going to send me to some ship out of like Norfolk, Virginia or something, and not anything bad to say about Norfolk, but it's not Australia. Anyway, so I said I'm going to get out of the Navy, and I went and came right down the street here to a little place called Harvard, which is where I got my master's in education. So I spent a year there. It was awesome. And I learned a little bit about teaching. And then I spent that summer in Ireland, which was cool. I worked for the Let's Go travel guide. It was awesome. I actually spent the summer going around Ireland writing travel books, which was cool. And then I came back and went to work at Brookline High School, also kind of around the corner. Anybody from Brookline? Anybody want to go to BHS? Who's your physics teacher?
No, I went to.
Oh, you went.
Baker.
Oh, you went to Baker. Okay, cool. BHS. Who was your physics teacher?
Miss Kissel.
Stacy Kissel, one of my favorite people in the world. She's awesome. Isn't she awesome? Yeah, she's awesome. Yeah, she lives right down the. She lives right down the road from me. She was actually my I was student teacher underneath her. So if I screw up, you can blame her, as it turns out. But in fact, I owe her a call. So what's your name? Kayla. I'll say hi for you. Anyway, worked at Brookline High before you were there, unfortunately, for about 7 years. In the middle is when I went to Santa Cruz, California for a year, worked at Pacific Collegiate School in Santa Cruz. Any Santa Cruz people? Keep Santa Cruz, what is it? Keep Santa Cruz crazy? No. It's like Portland stole it or something. Keep Santa Cruz weird, that's it. Santa Cruz is weird. Anyway. So I went from Brookline to Santa Cruz, and then back to Brookline again, actually, for a couple more years. And then eventually, my computer crashed, I think. Oh no, well, it's crashed. Oh well. Back at Brookline. I went back to Brookline, and then I taught there for a few more years, and then decided I wanted to get a PhD. So I went off to University of Virginia, which I can't show you on here because this has crashed. Hopefully the whole computer hasn't crashed. It hasn't. And when I was at University of Virginia, I was there for about 4 years, got my PhD in computer engineering, so not actually computer science, but I studied computer architecture. So we may talk a little bit about computer architecture as we go along in class, just because I like it. So we'll get to that. All right, and then while I was at UVA, still in the Navy Reserves. In fact, let me see if I can pull it up here. This is my alter ego. All right, Chris Gregg in Navy uniform. I'm a commander in the Navy. I may get promoted in a year or so. We'll see. I'm kind of hoping I don't, so I can just kind of say I'm done. But different story altogether. And so I'm in the Navy Reserves still, and that was kind of an afterthought, being in the Navy Reserves. But one of the things about the Navy Reserves is, first of all, they say every month you have to go somewhere and do some like Navy Reserve stuff. Well, it happens that right now I have to go to Seattle, Washington. I have to get myself to Seattle, Washington once a month, which is actually this weekend. So that's I don't really look forward to the travel. And then right before I graduated from UVA, the Navy came in and said, you're going to go to Africa for a year. And I said, oh, all right, I thought I was going to get a job. And he said, no, you're going to have a job in Africa. And and I thought to myself, this is awesome. I'll get to see like giraffes and elephants and all this stuff. I saw like one giraffe and it wasn't even in where I was stationed, which was a little tiny place called Djibouti, which is a tiny little country. Nobody's from Djibouti, are they? Where are you from? Oh, Ethiopia, right next door. Ethiopia's awesome. Djibouti, I don't know. It's dry and hot and deserty, and but I did fly through Addis a couple times while I was there. I didn't actually get out of the airport though, which just makes me sad. Anyway, so I was there for a year. In the meantime, Tufts had actually said, "Hey, come work for us," and I said, "Oh, I can't." And they said, "Okay, don't." And then, and that was going to be that was actually going to be the end of it, right? It was going to be, oh, no more, Tufts. I'll have to find a job somewhere else. In the middle of that, it turns out that they had some hiring, like some openings, and were able to offer me a job from over there. So that's why I'm here today, which is great, and I'm really excited about. Like I had a great semester last semester, learned a lot of things about Tufts and about Tufts students and so forth, and that's what landed me here. Okay. Questions on Chris Gregg? Yeah.
You do end up being promoted. Will you perchance be leaving us?
No. If I get promoted, I'll try to work locally. So no, don't worry about that. And they can't really. The good thing about the Navy Reserves is they can pull you up for a year, and then they basically say, we won't pull you back for another 5 years. So, at that point I'll be done. I can almost guarantee that. So, all right. So anyway, so that was me. We'll have one other faculty member, Bruce Mollet, who some of you probably know from Comp 11, who was going to help out a little bit here and there. He may run some labs. He'll be around for lots of help, and he's great. He's when you meet him, you'll realize he's great. He's always bringing popcorn into the labs, and yeah, he's fun. You'll see Bruce when he's around at various points. We also have a few graduate TAs. Okay, we've got a couple here now. We've got Tomoki. Where'd you go? There he is, standing in the back there. We'll be helping out in the labs and in office hours. And then we have Hugo here. Hugo's there. Hugo is the go-to person. I know you're going to get mad at me for this, but we talked about it already. Hugo's the go-to person if you have a Windows computer and can't get Eclipse running through the server. We worked on it yesterday, and he knows how to do it. So he's the guy to go to if you have any issues with that. Okay, How? You're not here, are you? Didn't sneak in when I... No. There's another TA, How, a graduate TA as well, called How, who's going to be doing the TAing as well. Undergraduate TAs. We have about 1 million undergraduate TAs, right? Is anybody in here TAing for Comp 11? One, couple people? Great, awesome. You guys will have the opportunity, if you want to sign up to get hired as a TA next semester. You got to do kind of well in here. But for the most part, it's a great opportunity to make your own, to get paid a little, A, and B, to enhance your own skills by helping other people, right? You only learn something when you teach it to someone else. That's like kind of the mantra, right? So that's it. But anyway, there's 1 million of them. TAs, the undergraduate TAs will be in the labs very frequently. There will be a schedule up once we figure it out. And then they will be running many of the labs. I'll probably run one lab. And then they will also be around for extra help. So there's lots of opportunity to get help if you do need it. Okay, questions about the staff? All right. All right, who is this class for? Right, well, this is kind of, I want to start out on day one by telling you a little bit about this, right? First of all, the class is for CS majors, obviously. It's one of the core requirements to be a computer science major at Tufts. And you have to take this class and then 4 other upper level classes, okay? If you're a CS minor, this is also for you. I don't know if it's 100% necessary if you're a minor, although most of the upper level classes require Comp 15, so it probably is in that sense. Other majors that have Comp 15 as a requirement, like cognitive brain science. Any cognitive brain science people in here? Yeah, awesome. You guys are great. Cognitive brain science is required to take this class, but as a requirement for the major itself, right? I realize that some of you, some people who happen to be cognitive brain science fit in this camp, some don't, may not be like, I really want to do computer science. Like, you want to do cognitive brain science, right? You don't want to, like, computer science is kind of like, all right, I have to take this class, I'm going to get through the class. I want this class to be for you as well, okay? I don't want this to be like I have to like love programming on my own time to do well in this class, right? I mean, I want you to be able to do well in this class, even if programming is kind of like, oh, okay, I'll do it because you're making me do it, right? I mean, I love people who love computer science, obviously, but I love people who don't as well, and I want you to do well, okay? Meaning I don't want to scare you from this class. Like, there are some hard assignments, and you are going to have to learn a lot of stuff that might tax your brain a little bit, but at the same time, I don't want to like stress you out about it, okay? This class is also for anyone else who wants to take more than just the basics of programming. Like I said, this is the class that really gets into the meat of computer science. Like, this class starts you thinking in a computer sciencey way. Professor Sheldon would say that Comp 11 does, and it does to a certain extent. But I mean, in here, we're going to start really talking about why computer scientists make the big decisions they do when they're programming. Okay? This is not a programming class. Like, I mean, don't think of this class as, oh, it's my second programming class, right? This class, we use programming as a means to an end, right? We use programming to learn all these data structures. Okay, so that's kind of the big idea there. Okay, now there are a number of freshmen in here. You don't have to raise your hands. You wouldn't want to, like, have to raise your hand on day one as a freshman. But for those of you who are freshmen, if you haven't talked to me yet, that means that you signed up and got past me somehow, right? Please talk to me before, hopefully after today. If you don't talk to me right after class today, email me and say, hey, I'm a freshman, I signed up, here's my deal, right? Here's why I say that. A lot of people come in here and they've taken AP Computer Science, which is great. It happens to be in Java, which is a different programming language than C++, and this class is in C++, and we jump right in. Okay, I mean, I'm not going to sit here and teach you what a for loop looks like or what a function call is, right? You're going to have to know that already. If you've done Java, much of that is very similar. Java has classes, C++ has classes. Java has constructors, C++ has constructors, et cetera, et cetera. Java does not have destructors and does not have memory management, which is part of what we're going to be doing in here, right? Java is what we call a garbage collected language, which means it does all that memory management for you, which is good in some cases and not so good in other cases, but it abstracts away some of the underlying machine, and you do need to realize that Java is different. Now, if you're a freshman and you got a 5 on the AP exam, I'm pretty confident you'll do all right in the class. If you got a 4 or below on the AP exam, please talk to me, okay? If you have other reasons why you think if you've been doing computer science, like programming stuff since you were 6 and whatever, talk to me, okay? Bottom line there, all right? You're welcome to take the class. I don't want you to be struggling when you could be taking Comp 11 and doing very well and getting a very good background in C++. Does that make sense, everybody? Okay, all right. So anyway, this class is for a lot of these different people. That's not to say that it's not going to be hard, but it's going to be doable. Okay, and again, we have lots of TAs and lots of help for you when you need it. Okay, questions on that? All right, where are the resources? This is the key one. Okay, the website, http://www.cs.tufts.edu/comp/15. That will be the main point of entry for the class. It's going to have your assignments. It's going to have the labs. It's going to have the information about how to sign up for labs. Okay, go to that website. Make sure you go there around 6 p.m. Well, I hope the server doesn't crash when you all do that right at 6. Oh, well, we'll see. Send me a screenshot if it's crashed. OK, the other one is Piazza. Most of you in Comp 11 know all about Piazza. That's just a forum. If you got the email and you had no idea what it is, go on there, sign up. You'll see it's a forum. It's a good way to get information. We will pass lots of information back and forth on Piazza. What you can't do on Piazza is post big sections of code. Don't post, you can post a little why isn't, what's going on here? And then somebody will say, you forgot a semicolon and blah, right? But don't go and post all your code, because that's not the place to do that. Okay? I already mentioned the office hours. I haven't really mentioned office hours. My office hours are on the website. A lot of times my office hours get a big line outside. Okay? In some cases, instead of waiting in that line, you might want to just email me. And if you really need to meet with me specifically, then we can find a time in 20-minute chunks or whatever. There are lots of other office hours for TAs. Okay? And most of them are in the labs. Okay, I already talked about YouTube. Email. So I mentioned this earlier. Feel free to email me, but once I get too many emails, like anybody else, I start to it takes a little while for me to get back to you. So I'll try to reply as soon as I can. If it's an email that you think just think about whether or not it can be something you can post on Piazza versus emailing me. Okay? If it's something about, what I didn't understand this in class, you might want to put it on Piazza first or ask a question during the next class. Okay? If it's a question about logistics or whatever, sure, email me. Or put it on Piazza. In Piazza, you can also do private messages for TAs and instructors only as well. Questions on that? Okay. All right. Textbook. So there is a textbook. It is by a guy named Mark Weiss. And you can get part of the textbook, which is this, in the bookstore. Okay? This is actually many of the chapters in the book, but not all of them. Some of the chapters I didn't put in. They gave me the option of doing this, and they said it's going to be like $50 less for the students. And I said, that sounds probably better than making you pay the full amount for a book you wouldn't use. Now, you can certainly go and buy the regular textbook, pay more, and get more chapters, but you won't necessarily need to. You don't even need to buy this if you don't want to. You can, and it's a good reference, and we will be having assignment or a reading out of it. I won't actually have assignments from that. But there is a second book, which is available online for free, which I will also be assigning readings from that are similar to the readings in the other book. They don't overlap exactly, but they'll get you the basic ideas. Okay, so either one of those is perfectly fine. Okay, questions on textbooks? Yes?
Sorry, it's not textbooks, but it's like resources.
Yeah.
You said you're doing the YouTube videos. Will you have
Yep.
any notes online?
So if I do a PowerPoint, and most of the time I'll have PowerPoints. We won't always use the PowerPoints, but in fact I can put this back up a little. But most of the time, I'll have the notes available. So anything we talk about in class should be available online. Okay. If it's not, remind me, and I'll put it. I try to put it there. The day before the lecture. Sometimes it takes me until the morning of, but that's my problem. I apologize. So that's that. Yeah.
I have a textbook that we used last year in Com 15. Can I use that?
You have a textbook that you used last year in Com 15.
Last fall.
Most of the readings you could probably find in that textbook. I don't have them. I don't know which ones they are. And if you can't find it in there, just look at the free one. I mean, I think you'll be okay. Okay. Don't tell the bookstore I said all this because they want to sell you books. But that's that. Any other questions on that? Logistics? Okay. All right. So here's some of the expectations. As I said, C++. Okay. The assignments are going to be in C++, and you need to become a decent C++ programmer. For those of you who are freshmen who have never, or anybody else who's never programmed in C++, you're going to have a bit of a tough time. Last year, due to a completely different reason, last semester we had a number of people who came in and they had never done one bit of code in C++, and they had a hard time getting up to speed. So not to scare you, but just to say that there is going to be some learning curve for those of you who haven't done C++ before. Okay, again, Comp 11, if you haven't taken Comp 11, it is an option to take that before you get into 15, and you will learn C++. Now, C++ is not a particularly fun language. All right, some of you guys might love it. Great. I'm not a huge fan of it. I think there are other languages which do some things better than C++. However, C++ is what we call closer to the metal. Right? C++ has arrays that you can actually get the address in the computer where that array lives, and you can manipulate it at that level. That's what pointers are all about, right? And C++ allows you to do that. One of the reasons we teach the core courses in C++ is because the next course after 15, anyone know which one that is? Comp 40, which you may have heard about, which is a difficult course. It's called Comp 40, kind of the joke is that it's 40 hours a week in Comp 40, right? It's a difficult course. Well, Comp 40 is in C, not C++, but C, which is even more like lower level. Like there are no classes in C, and there are no real data structures built for you except for arrays, right? So that's part of the reason we do that. Now, on the other hand, learning C++ is kind of like having your first car that you learn to drive on be a Ferrari. right? It's like you're going to grind the gears all day, and then you're going to like burn out the clutch, and you're going to like burn the tires down or whatever. But at the end of the day, if you learn how to drive that Ferrari, you can drive any other car, right? Because like most other programming languages are a little easier to learn than C++, and if you learn C++ enough, you'll be able to transition into other languages pretty easy. Not true about a language like Python, which is kind of the exact opposite. Python is like really easy to learn, right? And Python's like, you can get up to speed in Python very quickly. And then going to C++, you'll go, well, what are you talking about memory management? What does this mean, right? And things are a little more verbose in C++ too. So I don't love it for this class, but it's what we're going to do, and we will do fine with it. But just know that there's a little bit more to it than you might expect. Yeah.
Are we going to have any time in the lab for just a quick syntax review, or do you have any resources?
We're not really going to take lab time to do syntax review. If enough people want it, we'll probably try to schedule some TAs to give here's an overview of C++. There are some very good online tutorials. C++.com, and it's plus.com, I think it is. C++.com has some pretty good tutorials. You might want to get up to speed on that. So the first assignment, which we'll talk about in a few minutes, go ahead and look at that. And if it scares you, then go to C++.com and try to figure it out. And start early. What I'll say about that. Other questions on the language? Okay, I really don't mean to scare you. I just want to get the expectations out there early. Okay, more expectations. You have to take the time. I literally just got an email today from a student last semester who said, I'm kind of upset that you didn't tell us that the first homework assignment was going to take as long as it did. I'm like, you didn't look. I gave him like 2 weeks to do it, and he said, I looked at it 3 days before, and I didn't have time to finish it. I'm like, well, that's not my problem, right? I'm assigning assignment right now. You've got a week. You've got basically a week and a half to do the assignment. Start looking at it like tonight, right? If you don't know enough C++, well, then you got to get online and start learning it. So there's some things that are happening now that you need to be ready for. All right. Please don't wait to the last minute. It is always true. Correct me if I'm wrong. For those who are in Comp 11, the day before an assignment's due, the labs are jammed. Right? And the TAs are like going crazy trying to answer everybody's questions, and it's crazy, right? Don't wait till the last minute. I know some of you aren't going to listen to me, but please don't do that. Okay? Follow the directions. We're going to auto-grade a lot of this stuff, and I'll show you what that means in a couple minutes. But when auto-grading cannot read your mind, if I ask you to do an output where it says, or if you have an input string and the assignment says, read a string from standard input, and you put in there, please enter your string, right? The autograder will say that's wrong because we didn't say please enter a string. We just said take input, right? Computers talk to each other all the time. I don't know if you know that, but computers talk to each other more than they talk to humans, right? As it turns out, and they don't have all this like, would you like to be my friend? Sure, I'll be your friend. Let's talk. No, they just do it, right? I mean, there is handshaking, right? I mean, there is handshaking, but it's minor and it's very, very well defined because computers cannot read your mind. So our auto graders cannot read your mind either. Okay? We will try to grade the assignments in a timely manner, meaning we'll try to get them back within a week or so for the big projects. We'll give you feedback. Take the feedback seriously. Meaning, if you're having trouble, like if you had trouble with something, we'll give you feedback on it and try to come for help if you don't understand why. Yeah?
I know in Comp 11, when you submitted your assignments and such, it would give you feedback if something was wrong. Does that happen?
It depends on the question is, do you get immediate feedback? We're going to try to do that. I'm going to show you what the first assignment is. The first assignment will give you as much feedback as you can expect. There's like a ton of feedback. I'll show it to you in a sec. Yeah?
Also, is there still going to be the submission limit?
For other classes, you have a submission limit. What was the limit? 3. I'm going to make the limit like 100. So in the sense of, you can submit as many times as you want, right? Some of the feedback you get instantly will not be exactly how we grade it. We reserve the right to make any other tests we want on your code, and that will be, the way it goes. The next slide I think talks about this. Nope, the next one after this. You have to test your own code as well. Okay. For those of you who have never been in a CS class here, you have no idea what this means, but you're going to submit assignments using this thing called provide. For those of you who are in Comp 11, it takes what, about a week to figure out how provide works and then all of a sudden you're like done with it? Provide is really pretty easy. In fact, we will give you make files that automate the provide part too. So it's actually pretty easy. It's all online. You'll see how it works when you get to your first lab, actually. Okay. We will be using the servers from the CS department, and they are Unix servers, which means you have to what we call SSH into them if you haven't done that before, and I know most of you have. You have to become familiar with the Unix shell. Generally, what I like to do is kind of at the beginning of every class do a little Unix tip of the day, so you'll kind of get more and more familiar with it as we go along. I mentioned this earlier. I do suggest using Eclipse. I will show you this in a little bit. I'm going to not make it a hard requirement. You can use any editor you want. Everything is online. You can do it however you want. I would suggest using this developer called this integrated development environment called Eclipse because it allows you to debug your programs in one window right there, and it tells you exactly where the problem is, and it gives you all the data like what's I equal to right now. And it's done, right? So I'll show it to you. It's pretty cool. There's actually a little video, which is assignment 0, which will also show you a little bit about how to do that. And you said it was somebody said it was pretty good. I forget. Yeah, it worked out all right. Question?
Will you be able to use this like Eclipse through Windows?
Yes. Check Piazza. We just had a post about that this morning. You can use it through Windows, and Hugo's the one to go to if you have trouble setting that up. It basically goes. You run the program Eclipse on the server, and then it feeds you the windows on your own computer. Okay. So if you happen to be off campus or like home or something, it might get a little slow. So you are completely welcome to install your own version of Eclipse on your computer, and then you'd have to just transfer the files back and forth. But you can do that. It's kind of a pain, but you can do that. You can also use Xcode. You could probably get away with using Visual Studio, which I think is available for free, which is a Windows program. Xcode's a Mac one. But there's other options if you don't want to use Eclipse. But I think you'll get used to it and you'll say, oh yeah, this is cool. All right. What else about Eclipse? Benefits. Your files are all in one window, right? In C++, we have many different files that all work together in one program, right? Well, in Eclipse, they're all one window and they're right there. It's cool. Debugging. It's all, like I mentioned, it's pretty good. I'll show you Eclipse in a few minutes. We're getting close to time here, but we're good. I don't know why this slide has all of a sudden popped up, but plagiarism. Don't share your code. You can help each other. I want you to work together on things. But there are times where I see like two pieces of code and they both have the same error and they're obviously from two friends, and you're like, look, don't do that, right? Don't like write your own code and discuss it. I mean, that's the bottom line there, right? I do want you to discuss the assignments. You can, if you talk to somebody about a particular algorithm or data structure, cite them in your README file, which you will have to provide, right? Say, hey, I got help from so-and-so, right? It's easy to do. Don't copy code from the internet, obviously. Don't ask like homework questions on Stack Exchange. If you have a question about data structures, you should probably first go to Piazza. And if you have a question that's generic enough that you just want to know more information, sure, put it on Stack Exchange. But don't say, I don't know how to implement a linked list, blah, right? First of all, they'll yell at you and say that's a homework assignment. And second of all, there's lots of other resources online too. Okay? I put this in here in case somebody says, I own that code. No, we own it, but don't worry about that. If you write something amazing, we'll talk. Like that you want to go get money for, we'll talk. It's getting harder to get away with cheating. I'm just warning you now. There have been people caught for cheating in CS classes, and it's harder to do and probably harder than you think. Okay. Look at the, question.
Are you allowed to reuse your code from previous projects?
Sure. If you want to reuse your code, you can do that. If you have a linked list that you wrote in one assignment and you want to use it for a future assignment that needs it, yeah, absolutely. Yep, you can redo that. And you might want to put that in your README. I said I wrote this for my first assignment or whatever. That's cool. Yep, good. We're going to put the grades on Trunk, right, which is a different website. It's just going to be it's easier for me to add the grades so you have it all in one place. You should not be surprised by your grade at the end of the semester, right? What does that mean? It means that as we're going along, you should kind of get a feel for how your grades are turning out, right? It's pretty standard. If you think you're going to struggle with the assignments, I'll say it one more time, put in the work at the beginning of the class, because by the end of the class, let me put it this way, the last assignment is, it's a pretty darn big assignment. And people look at the last assignment in the class and they go, oh my gosh, I'm not ready for this. And you go, well, if you've been kind of paying attention the whole semester, you'd you'd be pretty close to being ready, right? So I mean, it's like there's a lot of learning going on like at the beginning of the class that you may not realize because the assignments are a little bit easier, okay? And go to office hours, all right? Okay, assignment 0. This is the one where it's how to learn how to use Eclipse, right? And going and logging into the homework server from your computer. You do have to log in to Eclipse. You have to log in when you do it. I'll just show it to you. You have to log in using what we call SSH-X. Can everybody read that? Here's what I'm doing. I've got a terminal up on the screen, and if you're on a Mac, this is built in, by the way. The X part is not necessarily. But what happens is you will do an SSH-uppercase X, and then your username at homework.cs.tufts.edu. Okay? And then when you do that, it logs you in. I have it set up so it doesn't need a password. You can do that too. You can look that up online. It's kind of cool. Or you type your password, right? And then this will come up, and you will, most of you guys from Comp 11 know all about this, right? But what you can do is, actually, I think I have it set up here already. I have homework 1 on my computer all set up for you. Notice on this little list of files that I have here, there is this thing called a make file. I will talk a little bit more about that later. Make allows you to compile your programs without typing that whole string of all the different pieces of the program, right? It's kind of nice. But let me first do Eclipse here. So we're going to, Eclipse, E-C-L-I-P-S-E. All right. Oh, yes, thank you. I will go down a bit. And you have to hit the middle one too. Cool. All right. On Eclipse, I'm not going to go over the details of all this. It's in the video. But basically, when you run Eclipse, it pulls up, and hopefully it's going to be fast enough in here. It pulls up your program, and you set it all up so that it has the files from your system. And notice, right, like this is the container program from earlier today, right? You've got, here's all the files I had from it right in here, right? There's my linked list. There's my hash table. There's my dynamic, what else? My tree, right? And then the files come up here, and you can go between them. Whoops, that one you can't because I didn't open it right. But you can just type the code right in here. When you make the code, right, you click one button, and it builds it all for you and tells you what the problems are, right? Like for instance, let's say I called it an unsigned int instead of an unsigned int, right? First of all, it tells you, hey, I don't think this is right. It tells you right there. And then when you build it, right, it will go ahead and build it and put the errors in there, right? And it says, hey, what's the problem? And it tells you what the problem is right here. We're using a compiler called Clang. I believe most of you in Comp 11 use GCC, or G++ rather. We're going to use Clang++, which gives you better error messages, right? Like it says right here, it says unknown type name unsigned, right? And then it points to where in the line it is. And then you go up here, and actually I believe if you click right here, yep, I clicked right there, and it takes you right there. Ooh, that's nice. Right? So it's like really nice to be able to do that. And then you go, oh yeah, you're right, I do that. And then you put that there, and then you rebuild it, and everything's good. Right? You can debug in here. I won't show you this part right now, just in the interest of time, but you can debug in here. I will go over some debugging things, but you can run the program. You can actually click right on a line, and there. I don't know if you can see this right here. There's a dot right next to the line. That says I just set a breakpoint on the line, and that breakpoint, when I run the program in debugging mode, it will stop right there and say, what do you want to do? And I can say, I want to see what all the variables are right now, and so forth, right? So it's pretty cool. This will help you a lot when you get to linked lists and try to debug the linked lists. OK? Question?
Yeah, I see there's a tab there that says debug. What
yes.
debugger is it using?
I believe in the background it uses GDB in the background. And if you want to use GDB from the command line, by all means. If you know enough about GDB or the other debuggers, by all means. Yes?
I've been using Eclipse for a while, but
Uh-huh.
it's been for Java. So.
Yes. If you install this on your own computer, you have to install the CDT version. CDT, which is like, I don't know, C something, language business. But you have to do that. So yeah, you can do it for Java, or they have C++ plugins for it. Yeah. What's that? CDT, I think, is the name of the if you look up Eclipse CDT, it'll say, oh, for C++ programming.
Is that an add-on or just a new Eclipse?
It's an add-on. Yeah, although you might have to download it the same. Yeah. Other questions on Eclipse? Yeah.
The one that's running off the homework server, is that already?
It has everything now. OK, when you did it from did you follow the whole directions? did you get to a point where you couldn't find some of the things I said in the video? Or did it work all right? Okay, in some cases, it will come up and it doesn't, for whatever reason, the first time you run it, it doesn't necessarily know you want to do C++. Sometimes you have to close it and start it again, and then when you restart it again, it will know. So, but yes, it's already installed.
Is that like every time you
No, just the first time. I don't know why it does that, some bug. Yeah.
I had to add the debug in the C++ at the top.
Oh, you had to add this? I believe on the first homework assignment I say that you can do that too. I think that's different than the video, but yeah, good. Other questions on Eclipse? I do, again, use whatever you want. In lab, the first day in lab, we're going to have the TAs go over how to set this up and use it, but I think you'll find it good. Yeah.
when we SSH into the homework server,
Uh-huh.
what username should we use?
Good question. When you SSH into the server, you'll use the CS username, which you all should have at this point, but you may not. One of the parts of homework assignment 0 is go figure out how to get that set up. I will, in fact, if someone reminds me right after class or sends me an email, I'll go check and see if they've made your accounts yet. But you do need to use the CS one, not your account that you got when you first got here. Make sense? Okay. All right. So let's see. So that's Eclipse. I think that's enough Eclipse for right now. Here we go. I'll show you how to make the program, right? If you type make clean, what that does is it actually runs your, pay no attention to that, that was Eclipse ending. It runs your make file, and in fact, well, I'll show you how to do this, then I'll go back and show you the make file business in general. To make the file, or to compile your program, you just type make, right? And it's all set up already so that it says Clang++, then it has a couple flags, and it puts out all the files and then does it. And then whatever the make file says, it puts your program down here, right? Like ./hw1. And if I do ./hw1, it runs your program. And this is what it happens to run. Assignment number 1 is all about, it involves a deck of cards. Okay, so you're actually going to be doing kind of the back end of this whole thing. But you can kind of see up there, it's kind of listing a whole bunch of cards, like 8 of clubs and 10 of clubs and so forth. When you go to submit the assignment, all you do is you type make provide, right? And for those of you in Comp 11, you're like, oh, that's cool. I don't have to type the whole list of files. We've already got it in there. I'll show you that in a minute too. Watch what happens when I'm going to clear the screen. Watch what happens when, in fact, I'll make this bigger. When you do make provide, this is what hopefully will happen most of the times, right? It will do this little provide script that's in the background, and it'll say, hey, look, here's all the files you're supposed to be submitting and some more information about it. And then it will say, I've actually submitted 23 times because I was testing this, right? It looks like. But what you do is you type yes, and when you're ready to do this, and it goes through and it copies all your files from your directory, and then it starts running these tests, right? And this is scrolling by pretty fast, but you can certainly go back up, scroll back up and see what it does. But it does all these tests. Right now there are a total of 12 tests, I guess. Yes, 12 tests. And at the end, it said some of the tests failed, right? And you go up and you go, look, all those ones passed, all those ones passed, all those ones passed. Oh, aha, this one looks like it failed. So it failed the second test. I purposely put a little bug in there that would make this fail. And what it's going to do, and this is probably different than what Comp 11 did, it's going to give you the program that we created that you can then copy and see if it works for you. In your, it tells you exactly what the part of the program is where it failed, right? And then, it doesn't tell you where, but it tells you that it failed. It tells you what the expected output was supposed to be, and then it tells you what your output was. In this case, it says got signal 139, which says it's a seg fault, which is bad news. It means you did something wrong. In this case, I had a counter going up instead of down. That's all I did, right? And it tells you exactly how to do that. So these are some of the tests that you'll get when you do the provide, okay, which we're going to try to keep this up and make sure that it works for all these assignments early enough so you have time to fix your issues. But that's how that's going to work. Okay, questions on that? Yeah.
Will we learn how to make a makefile in lab?
You won't learn how to make a makefile in lab. You can look at any of the makefiles. Makefiles are coming up in about 2 slides here. But I'll go over some of that. And makefiles are not very fun to use, but I mean to create, but they're not too bad when you do it. All right, first things for while we have time, first assignment. Assignment 0 is the Eclipse assignment. That's just watch the little video, figure out how to get Eclipse running on your computer, try to do that. Assignment 1 is the first like major assignment. It's kind of like a project. If you took Comp 11, it's kind of like a project in Comp 11. It is due Friday at midnight, Friday the 12th at midnight. That's next Friday at midnight. And look, as far as I am not going to put a little timer on the provide script that says you're done submitting. If you submit a few hours late, fine. I put the time there as midnight so that hopefully you prepare well enough and don't like spend all night doing it. But if you're going to like spend more time, don't email me and say, oh my God, I didn't submit it until 2 minutes after 12. So don't worry about that. Worry about getting it like, completed in a more or less timely manner. If it's due on Friday and then Sunday I get an email from you saying, oh, I didn't quite submit it yet. OK, you probably should have emailed me sooner, right? But in general, submit by the due date. OK, the first assignment is going to be on dynamic arrays. I already talked a little bit about arrays. Monday, I'm going to talk more about dynamic arrays. And that's going to be what the first assignment is going to be all about. But I do suggest you take a look at it now. What I'm going to provide you, especially for this assignment, is a lot of what I call boilerplate code. What that means is it's going to be a whole bunch of files, and you're only going to have to put little sections in and write little sections of the code, right? You're going to have to write a total of 13 different functions, right? But some of those functions are 1 line long. Some are like 7 or 8 lines long. But that's it, right? You will know exactly where you have to write those functions, and then that'll be that. As we go along, I will give you less and less boilerplate code. Eventually, I will give you a .h file that says, here's the interface. These are the functions you have to write. Go write them, right? So it's going to get a little harder as we go along. The first assignment, I don't want to be too overwhelming. OK? Questions on that? Yeah.
How many assignments do we have?
I think we're going to have 7 total assignments, like 7 projects total. Yeah.
So it's not like assignments and big projects?
No, they're not going to be like Comp 11 where you have homeworks and then big projects. They're all kind of big projects in the sense that they all take a week or 2. Yeah. Yeah.
It's actually a question about provide. Since
Yeah.
I've never used it all
Sure.
before. Is the makefile given to us like how are we going to get our hands on the provide makefile?
I will give you the makefile for probably every assignment except maybe the last one. So you might have to do the last one on your own. But it's honestly, you copy the one from the previous assignment and fill in the details. I mean, it's not that bad. OK, let me get to a couple other things. Makefiles, provide a makefiles. What's a makefile? This is what a makefile looks like. A makefile has it basically. Well, I can show you. The first, like, if it's got a hash, it's a comment in front of it, right? You've got the compiler listed. You've got various flags. You basically have some dependencies. Makefiles are cool because the program make sees if your files have changed. That's kind of why it was built. Like if you haven't changed a file, it doesn't go recompile it because it knows it's the same file as before, right? And then you extend the line by a backslash. You can look at this online, by the way. Makefiles are weird. They need tabs, not spaces. That confuses some people. They need tabs before like main lines. Okay, and then you've got command line compile. So this part, you've probably seen this before if you've used, like you might normally type G++, maybe some flags, -o, homework 1, and then the first CPP file, the second CPP file, right? If you've done that before, the makefile does it all for you. It's kind of all built in there. Okay? Then you also have the ability to clean. In other words, delete what you made so that it remakes the whole thing. And then the provide, which we already talked about. This should look familiar, and for those of you who took Comp 11, right? This is your provide script with all the files that you need to provide. And just make provide does it for you. Okay? A little easier. I want to make things a little easier if we can. Okay? All right. I've already talked about C++. You're going to have to know it if you don't already. Auto grading, I already talked about this. Your test. You've got to write your own tests. We'll talk more about this on Monday. I'll show you some of the tests. You can see some of the tests by writing poor code and making doing provide, and then you'll see all my tests. So you'll get a feel for how to write your own tests. Okay? I don't have sympathy for, oh, I didn't test for that. Well, we did. So you need to learn what corner cases are. Every data structure has some sort of case that's odd, that's different than the other cases. At the end, if you're inserting something at the end of an array, it's different than at the beginning. Or if you're inserting at the beginning or whatever. So there's corner cases of these things that we need to worry about. Question?
Do we need to worry about like you guys trying to test for something outside of
Nope. And you will, trust me, everybody in class will yell at me if I try to test something that you didn't know about. So we do the best we can about not testing something you didn't expect, in the sense of the data structure. I mean, if you didn't expect a corner case, well, too bad on you. But we won't test stuff that I didn't expect you to do. If you find the assignments easy, awesome. I'm very glad you find them easy. Make them better. Give me a main file that does something cool. If I don't particularly say what your main file has to do something cool. Tell me about it in the README file. I'd love to read about it. Don't think, oh, these assignments are so easy because they're kind of basic stuff. Expand on them if you want. Make sure that our tests will pass, but do as much extra as you want to. Okay? Assignments, passing the test, code style, README files. Read this on your own. Get to know what we expect. We expect clean code. Eclipse will make your code beautiful, so don't worry about that. Okay? I'll talk more about the actual assignment on Monday. If you have questions, stick around. You can fill out the drop form or add form if you want, and I will see you guys Monday.